Okay, so since the last time I streamed, which I think was probably this commit on April 1st, I haven't done much to the actual library. Just a few things, because I've been, as the stream title says, I've been contemplating constantness. And so, well, I guess first I will give a little overview of this. Well, these commits don't really need overview. This top commit here, the latest one, does have to deal with constantness and how I probably will be changing constantness. Constantness, I wasn't always sold on exactly how I had it semantically, but that's what I'm going to go over in this stream. Last time, unfortunately, I didn't have audio, but I was going over the link statement that, well, is now the link expression for dealing with statically linking, dynamically linking, and dynamically loading. And for that, even, I had researched I found to be, let's see if I have the image in here. Add existing, yes, here we go. I have it readily available. What I found to be 9 different ways to link / load. And my original motivation, as if you go back and see the stream, or you look at the stream notes in the actual libwy GitHub, I have the only stream notes in there I have from last time when I listed basically what I had researched about these times of linking and loading. I almost forgot to send that. Okay. But yeah, so the ostensibly what I found to be is that, linking and loading, you can of course do them at different times, and static linking, dynamic linking, and dynamic loading kind of show this subtler form of, compile time, init time, and runtime. And of course, as you can see on this graph, or chart, I should say, they happen at the same time for them. But you could think about whether to do them at different times. And if you didn't see the stream, ostensibly, basically what it came to be is that I don't really need to, because of course this is for the link grammar. I wanted to make sure I wasn't, cutting myself off if I was only doing static linking, dynamic linking, and dynamic loading. But all the other ones are basically either useless for library design, like these down here. Oh, my mouse is in the wrong place. I have my mouse hovering over that, not. Ooh. Well, I think it'd be a pain to put my mouse over it. But basically, the runtime linking and lazy linking are basically. You don't do that. Except for actual like user stuff, like, oh, I made a tree, and I have to allocate stuff at runtime. It's not useful for libraries. And then some other things like these mixed ones over here. These are what originally led me to thinking about linking and loading. Unfortunately, they're very nuanced, and it's not a clear decision, like, or as clear a decision, I should say, as you have with stuff like static linking, and dynamic loading. But yeah, so that was last stream, and I can make that go away. And so since then, like I have here, I have very little in here because I've been thinking about constantness quite a lot, because there are a few ways that I can deal with constantness, and this I shouldn't have come in here yet, because actually this came down to when I was making the example in here that I showed off last time, I think at the very end, when I was dealing with showing the concrete and abstract hyperexpressions and what times that these make the expressions actually happen at. And I basically, this goes against what I've been thinking the whole time about constants, which is why I've had to go back and think about it, because this makes sense, but also is not how I've been thinking about it. And I had it originally how I thought, but then I thought, actually, this doesn't go in line with the rest of the stuff. So basically, that's why I've had to think about it. Because basically, in the whole library and everything else, I've been thinking about constants as constants default to things happen at compile time. And then you have to do abstract hyperexpression to make the expression within happen at init time. And then for non-constants, it's different. But that doesn't doesn't feel satisfactory. Because it basically, you have. I was purely thinking about when I was thinking that I'd have, say, constants would be default to compile time, and then if you put abstract, it happens at init time. I was purely thinking about actual compile time constants, and then like technically the init time would be a dynamic constant, but I wasn't really thinking about constants that, say, you have in a procedure that is based on a parameter, which, you know, you can't, that it's not a constant in the same way. So it, you know, it's been quite the time. So I'm basically planning on listing out the different ways I can do constantness in the language. So, like I said, currently there is, well, I guess technically I could say the first option is no constants. That is an option that I'm not going to go with. It's impractical, it's unoptimizable, maybe. Well, not unoptimizable, but like, you know, pretty hard to optimize. Yeah, like, I'm just gonna say not happening. So, the next option is what I have now, which is I have one type of constant. Or I should say one constant keyword. Because I've been thinking about having two, which, like, technically wouldn't divide it along the lines of completely compile time constants and dynamically sized constants, but or not dynamically sized, but dynamic constants. Um, you know, immutable variables. So one constant keyword. And right now that is at the beginning of the line. Of the variable declaration. Maybe it is actually my keyboard. I thought maybe my keyboard is actually, yeah, my keyboard is going bad. Ooh, that's not good. I was hitting A that whole time. Whew, that's not good. Okay. Well, unfortunate, but I'm just gonna keep going. At the beginning of the variable declaration, or at the beginning of variable declarations, or I should say only at the beginning of variable declarations is this one is like kinda magic. And by kinda magic, I mean it's not yeah, it's all the compiler doing stuff. It's not, because the problem with this approach, which I did think about after starting to think about you know, where these parts would be, where each of these approaches would be, would bring problems. I thought about the anywhere pointer type in the standard library. And so the idea of the anywhere pointer is that it just carries along with it basically a bool that tells you whether the data that it's pointing to is in the data segment of your executable. So it's something that you've pre-allocated. You have some, compile time constant or even init time constant. Some array of values or whatever. And you have one of these elements, and you point to that element. Or whether it's in the heap, whether it's been allocated by this procedure, because in some cases maybe you want to use a pre-allocated value for some inputs, but some you actually need to allocate data for. So that's the idea of the anywhere pointer, and that kind of doesn't work if the idea is that the data that it points to is supposed to be constant, because there's no way of telling the actual user of your procedure that it's actually supposed to be constant, because this is kind of magic. And, it's basically just here in the procedure. Basically, I was thinking, if you pass the variable through into another procedure as an argument, it would basically do some type of continuation style, context passing style. I can't remember what the name is for the compiler style, but basically, it would pass down the context of that argument when it's building that procedure, the procedure that has the constant in it, which does mean there'd be more global. It would be a more global optimization rather than a local one, which isn't great, especially if I want to do more global optimizations. I want to have most things be local, because that'll make optimization easier. So this kind of thing is insufficient. Basically, it would cause things to be global, and that's not good. So then the idea is, well, I guess technically as part of this top one, I of course have the const type in the standard library, but this doesn't really solve any problems with this style, essentially, because you'd still get you'd go to, let me pull it up real quick, actually. You wouldn't have So when you dereference the const, you wouldn't get the dereference operator isn't it doesn't have the become property, so you wouldn't be able to assign to that data. But it kind of becomes a problem when you introduce using member access. Because even if I say, like I have some type of, natural const, a, or not natural, I should say, well, natural complex, const a. Because then when I do something like a, and then I dereference it, I can still do like, okay, well actually, I don't have that interface designed right now, but let me just create a simple struct. To elucidate what I mean. So essentially, I could have like some natural value here, which accessing that, still I would have to make it so that member access. So if I had like an example const a, and I do a, and I dereference that, and then I do n. So I would have to somehow, like grammatically, this would still be, I could still assign it, to 5 or whatever, because it's an identifier. So I would have to somehow make, the member access now worry about, become operators, and like only pass that to it, like to the right side when the left side has it, and I don't think I have to do any of that if I don't do this. But even if I did do this, I would still run into a problem when I have like, a simple setter. It's bad form, but just to show my point, if I have some type of setter, and I just say this.n equals k, well, even if I said that, okay, somehow I pass the becomeness from left to right on the member, that means I can't go, star a dot n equals 5. But that doesn't stop me from just going, star a dot setter of 5. There's nothing here that stops that, grammatically or anything. So the const type is most likely getting axed. I thought when I made it, it was probably going to get axed anyway, but now I definitely know it's getting axed. So that's that problem. Of just having one that's at the beginning of variable declarations. And then the other idea is having like C style use of the keyword. So I would have, so of course in C you have, say like, an int star star star, and of course you can just put these stars all together. But the idea is then you could have const somewhere in between, and you have like const, and this, I mean, this does seem like a good thing to do because ostensibly, my type system, where I have, a chain of types, natural, complex, matrix, 3, 3, M. This chain of types was essentially how I was thinking about this in C, was that I just have a pointer type chaining to another pointer type, but in C, all you could do was pointer types until the last one. And of course, I could do the same in my language and have some integer pointer and then just keep writing pointer however many times. But the thing is, of course, this constantness problem. So I could take what's in C and extend it to how my type system works, which is how I'm thinking of doing it. And there is a little bit of a complex problem about that, but I will get into that later. So the idea then with this C-style use is that I would have something like, although of course, I will be going for the properties on the left. So, not constant. So that would be this pointer, this last pointer. So the root type pointer is constant. And then pointer, whatever. So if I wanted the same thing I have up here, down here, because technically, at least if I remember correctly, the const goes on the right of the type that it deals with, except for the few cases where you can put it on the left, like the far left one. But at least if I remember my constantness from C correctly, then to get this one up here in the C style into Y, it would be constant integer, constant pointer, constant pointer. Right. Or constant pointer, pointer, and then remove this one, yes. So be like that. But that's not the whole story. Because I can have types that work like this, where I have, say, an array of natural numbers. or integers, it doesn't really matter. And I have, what, a 10 long array of integers, or natural numbers. So the problem arises when I say, well, what if I make this array constant? Well, what does it mean for the array to be constant? Because, does that mean the naturals can't be constant? And of course, in this case, and for all, say, well, I'll get to that in a moment, but if you have an array and you make it constant, well, its elements are constant as well. You can't have a constant array without its elements being constant. So it's not as simple as, each step can be constant or not, because each type in the chain is not, well, or in the tree technically, is not purely a pointer, which is, a reference. And since I'm already adding a reference, a reference property for types, to allow for other types to have the same thing that pointer does, where you can have like, I should technically have that there, in how I was thinking. But basically, right, technically, if I want to be more accurate to at least how I thought about the C one, that should be a 4-byte integer. But anyway, because the pointer, of course, you can have pointers to abstract types. So, and this can only happen with references, because, of course, all values need to be concretized at compile time. So, in a concrete scope, all types in the tree, in the variable declaration, need to be concrete, except to the left of a reference type, because, of course, the reference type, for pointer, of course, you just have a number, so you already have a concrete type, a size of storage, all this other stuff, that make it concrete, even though it might reference a type that is not concrete. And of course, that's how you do runtime polymorphism. In the OO style. Well, technically it works for either OO style or procedural style, depending on where you put the argument. But yeah, so I was already thinking about adding reference types so that I can have other things like, I can have like an index, some type of, I don't know, object pool index. So you have some object pool, and so I can have other types that have this nice property of being able to have abstract types to their left, because I can have, I don't know, some type of mesh or whatever, but then I have, well, actually the mesh probably wouldn't have, implementations of an interface, but, if you have multiple types of things, I could have some type of reference index, and I can dereference that because because that's how the become property works. But because technically you do that on anything, but it's most useful, of course, for these reference types. And so, since I'm adding the reference property, that necessarily has to interact with this constantness, because the array type isn't a reference type. So the constantness, flows down into the type it composes. Because because also I'm going to have using the constant keyword on a type declaration, and what that would do is make all of its member variables constant. So if I have this, putting constant here at the top would be essentially the same as having constant for each of these member variables, at least on the root type. And because of course this is only one type, that's just constant on this type. Now, technically, this doesn't mean this would always flow through into the next type, that it would always make the next type in the chain constant by virtue of this constant keyword here, because I could have a reference type in here, but since for classes you're not supposed to know, or you're supposed to be able to work without knowledge of the internal data structure, that will have to act not as a reference type, or by default, I should say. Technically, you can make it a reference type, but by default, if I have some type of class, and I have, I don't know, so a resizable array, of course, in the standard library is a class in the manner in which I'm calling it, which is essentially Simula style, but not exactly, because of course I've moved everything to be to work specifically on the Liskov substitution principle. Not only because it's better, but also because then I don't need to use virtual procedures, which is, not great in other languages. So if I have some R array, and of course this R array is a class, then when I apply the constantness to this type, we have no clue what the internals are. So this has to carry down to the type it. One moment. Okay. So yes, since we're ostensibly supposed to be able to work with no knowledge of the internals of our array, it's just some interface to deal with it. The constantness would have to flow down into the type it composes. So the whole thing would be constant. And so to make it a little bit easier, I think for normal structs, it will also flow down even if you have some reference parameter, because usually when you have a usually when you have a reference type as the type of a member variable, of course the thing is you use classes whenever you have invariants that you need to uphold, and usually for reference types that is needed, because usually not all values of a reference type are valid for some struct, you know. For reference types, usually you cannot guarantee that it is referring to, for the resizable array, I can't guarantee that the pointer is pointing at an array unless I have it as a class instead of a regular struct. So, and like thinking about it, the few places where all reference types would be valid, I think is very very small, if not impossible, in it, an actual application. In any actual application of reference types, you would most likely need to wrap them, unless they're already constant, like in the stream type, because those are already constant. I think they're pointers in there. I don't remember if I put them as pointers or put them as just procedure types, but either way, they're already constant, so it doesn't matter. But yeah, so for those reasons, and because technically, like, using reference would allow you to kind of override this anyway, even though it also does a slightly different thing as, in addition, but it would also kind of allow you to override it. By even if you had, a reference parameter here, it wouldn't fall through to the composed types. Wait. If I had some, array it wouldn't work in the final thing, but eh. Um, but yeah, so like, well, I'll have a better example once I actually have the thing ready. Um, because I'm quite tired right now, and I just need to get this done. Um, and I hope this explanation was at least uh satisfactory on the constantness front. I'll deal with the reference front by themselves. I'll deal with how they interact later. Um, but yeah, or I'll deal with saying how they interact later, or communicating that, I should say. So this seems to be the approach. Um, so in the correct direction. So yeah, essentially looking at actually having two for optimization reasons, but they'd still work exactly the same as propagation as this one up here. But yeah, so I'll be back.